Hi everybody. Here is my attempt at the graphing motion activity here. Alright. We got the first problem here. A car travels at a constant 20 meters per second for 10 seconds. Fill in the table showing the car's displacement from the origin of each second. Again, I think I've mentioned this to many people that I've griped with, is that I wish this said position versus time. So that's what I'm going to say, position in meters versus time. But it's 20 meters per second for 10 seconds. And so I know the, right, so 20 meters per second for 10 seconds. So if it's 20 meters per second, that means every second that goes by, it is moving 20 meters. It's the rate of how much its position changes. So that means if it's moving at 20 meters per second, then after 1 second, it's moving 20 meters. And after 2 seconds, it'd be moving 40 meters. After 3 seconds, it'd be moving 60 meters. After 4 seconds, it'd be moving 80, 100, 120, 140, 160, and I guess I don't need the meters because they're already here, 180, and then 200. So that is what I'm going to be plotting. So I got my position in meters, my time in seconds. I already plotted these out because it takes a little while to think about what kind of intervals you want to use. But here I would have, let's see, I would have 100 meters, and then here I'll have 200 meters. So in between I'll have 2, 4, 6, 8. So this would be 20, 40, 60, 80, 100, 120, 140, 160, 180, blah. So at 1 second, which I have is here, so at 1 second I'll have 20. Let's make that a different point. So let's do it like that. At 2 seconds I'll have 40. At 3 seconds I'll have 60. 4 seconds I'll have 80. 5 I'll have 100. 6 I'll have 120. 7 I'll have 140. 8 I'll have 160. 9 I'll have 180. And then 10 I'll have 100 exactly. I can draw my best fit line. Alright. There you go. And then so the next thing they asked is for me to calculate the slope. So I'm going to say 0, 0 is my slope, a slope of mine. And then I'll pick this point right here. Even though it's a decimal point, I know I've been harping on that, but this is kind of ideal situations here. So I'll say at 10 seconds, 200 is the velocity. So to calculate the slope of anything, it's the rise over run, so it's the change, that'd be the change in position in this case because this is position. So x2 minus x1 divided by t2 minus t1. So that change in position, that'd be 200 minus 0 divided by 10 minus 0, which is over here. So 200 divided by 10, so my slope is 20, and the units are meters over seconds. So what's the slope? The slope is 20 meters per second. How does the answer in number 2 compare to the velocity of the given problem? Velocity of the given problem is 20 meters per second, so they're the same. So how does the slope of the displacement versus time? Again, I wish this was position. But displacement is fine because we're starting at the 0 point. But what's the slope? It's the velocity. Alright, next up, complete the tables showing the car's velocity at the end of each second as it moves 20 meters per second for its velocity. So if it's moving at 20 meters per second, at a constant 20 meters per second, and I'm making a velocity versus time graph, again the units would be meters per second and seconds here. But if I'm doing a velocity versus time graph and it's moving at a constant 20 meters per second, that means that every second it's going to be moving at 20 meters per second. So if I did this at, let's say, 4, 8, 12, 16, 20, so this would be 24, 28, then I would make a graph that just goes straight across. Whoops. Oh, that's fine. And I'll use my straight edge. Oh, come on. There we go. Boop. There we are. So there's my line. And to plot my points. So again, this is going to be 2, 4, 6, 8, 10. You want to use as much space as you can. Again, that's really crappy there. So 2, 4, 6, 8, 10. And yeah, I'd have a graph up to 10. So we'll leave it about here, right? This kind of part of the graph doesn't exist. So it says find the area under the line for the first 5 seconds. So the first 5 seconds will be up to here. And so I'll find the area that's under here. Area is base times height. So the base is 5 seconds. And the height is 20 meters per second. So 5 times 20 is 100. And then meters per second times seconds, the seconds cancel out, and I get 100 meters. So the area under the line for the first 5 seconds, that's 100 meters. Compared to the displacement at the first 5 seconds in number 1, well, we know the displacement from here at the first 5 seconds is 100 meters. So again, they're the same. Then it says the area under the line for velocity versus time graph is the displacement. Alright, now on to this one. It says car starting from rest, so it starts at 0 meters per second. Accelerating at 2 meters per second squared for 10 seconds. Fill in the velocity versus time. So I've often said the best way to write this is 2 meters per second per second. So what that basically means is that this thing is speeding up 2 meters per second for every second that goes by. So if it's at rest, after 1 second, the velocity is going to be 2 meters per second because it's speeding up at 2 meters per second for every second. So at 2 seconds, it's going to be at 4 meters per second. At 3 seconds, it's going to be at 6 meters per second, 8, 10, 12, 14, 16, 18, 20. So I hope that idea, like that whenever I'm confused about acceleration, I always bring it back to this idea that acceleration is how fast, how quickly something is speeding up or slowing down. So it's how much it's increasing in velocity over time. So then writing my, I'll write this as 2, 4, 6, 8, 10. Again, the velocity. So this is time in seconds. And then velocity in meters per second. For velocity, I would say 4, 8, 12, 16, 20. So I'm trying to spread out that as much as possible. I might have been able to do better, but this is where I'm going to stay. So I got at 1 second, going 2 meters per second. At 2 seconds, I'm going 4. At 3 seconds, I'm going 6. 4 seconds, I'm going 8. 5 seconds, I'm going 10. 6, I'm going 12. If you want to skip the video of me plotting this, it's honestly not that exciting. And again, I can make my best fit line. There we go. So I want to find the slope of this line. Again, I'm going to say this thing hits 0, 0. And what the heck? 1, 2, 3, 4, 5. So I'll say this is 12 seconds. And I'll say it hits here at 12, comma, what would this be? This would be at 4 seconds up, so 24. So 12, 24. So now I will use those points. I'm also using 0, 0. Whoops. So to find the slope is the rise, the change in velocity over the run, change in time. Change in velocity would be 24 minus 0. 12 minus 0 is the change in time. So the slope is 2. And again, those units are meters per second over seconds. So it'd be meters per second or 2 meters per second squared. So we're going to put in here. How does it compare to the acceleration? That's this. So the acceleration is 2 meters per second squared. The slope is 2 meters per second squared, so it's the same. So slope of velocity versus time graph gives me the acceleration. Next up, it says complete the table of the car's acceleration at the end of each second as it accelerates at 2 meters per second squared for its acceleration. Then complete the acceleration versus time plots next to it. So in this case, it's moving at a constant acceleration, 2 meters per second squared. So if it's constant, the acceleration is constant, that means after 1 second, it's still going to be 2 meters per second squared. And after 2 seconds, it's still going to be 2 meters per second squared because it's moving at a constant 2 meters per second squared every second that goes by. So it's just going to be 2 all the way down. And that means for all these 10 seconds, it's going to be at, let's say that this is, well, first off, the units here would be meters per second squared. It'd be, so again, time, that'll be seconds. So I'm going to draw my best fit line because it's just going to go, it's going to be 2 meters per second the whole time. Oh, sorry, I'm calling this 2 meters per second. So I'm saying this is 1 meter per second squared. This is 2 meters per second squared. So it says find the area under the line for the first 5 seconds. Again, 5 seconds would be about here. And so I'm trying to find this area. Area is base times height. So my area is my base, which is 5 seconds, times the height, which is 2 meters per second squared. And that's going to give me 10. And then the 1 second cancels out here. So it'd be 10 meters per second. So this is 10 meters per second. How does this compare to the acceleration for the first 5 seconds in number 9? So how does this acceleration compare to for the first 5 seconds compare in number 9? So let's look at number 9. So the acceleration in number 9 was 2 meters per second squared. This acceleration is also 2 meters per second squared. So the acceleration is the same. The area under the line for the acceleration versus time graph is the, and it turns out this is the change in velocity. So you can think about this in this way. The acceleration is defined as the change in velocity divided by the change in time. So if I multiply both sides by the change in time, this would cancel out. And I'd have the acceleration times the change in time is the change in velocity. Change in time is the base, and the acceleration is the height. And that gives me the change in velocity, which is why the acceleration versus time graph is the change in velocity. Alright, couple other things here. So I got these questions for a position versus time graph. It's got all this crazy motion. What's the object's displacement in the first 5 seconds? Well, the displacement is a change in position. So in the first 5 seconds, my initial position is 0. My final position is 5. So it's going to be 5 minus 0. So 5 meters is the change in position. Now from 5 seconds to 10 seconds, I can see I get no change in position. So 0 is my displacement. What about displacement from 10 to 15? So at first my position is 5, then it's 15. Again, displacement is the change in position, so it's going to be 10 meters. So from 15 to 20 seconds, again I can see there's no change in position, so it's going to be 0. And then what's the object's displacement during the last 10 seconds? So from the 15 meter mark, that's here, to the 0 meter mark, that's here. So that'd be displacement is the final position minus the initial. So that's 0 minus 15. So negative 15 meters is my displacement. During which intervals is the object standing still? Well, I've established that from 5 to 10 and 15 to 20. Seconds. Now it asks me to calculate the velocity from 0 to 5 seconds. So a couple things you could do. One is the velocity is the slope of the position time graph. So you could calculate all the slopes. However, I found the positions already here. So I'm going to use the definition of the average velocity, which is the displacement divided by the change in time. They're telling me the change in time is 5 seconds, and my displacement in the first 5 seconds was 5 meters. So 5 divided by 5, it's going to be 1 meter per second. As we've established, 5 to 10 is 0, and 15 to 20 is 0. So to get the third velocity from 10 to 15, this is my displacement, is 10 meters, divided by my time, which is 5 seconds. So it's going to be 2 meters per second. And then lastly, for the last 10 seconds from 20 to 30, my displacement was negative 15. So that's going to be negative 15 meters over 10 seconds. And that gives me negative 1.5 meters per second. And that's going to go in there. Alright, almost done here. So lastly, I got this graph again, but careful, this is a velocity versus time graph. So that should have meters per second in it. And then we're trying to find out the acceleration. So the acceleration is the slope of a velocity time graph. So the slope here is the change in y, which is 5 meters per second, divided by the change in x, so that's this part, which is 5 seconds. So the acceleration is 1 meter per second squared. For b, again, I'll keep this at 5 seconds here, and then here is up to 15. So again, the change in x, change in the horizontal, is 5 seconds. The change in y is 10 meters per second. So again, if I wanted to find the slope, that's going to be the acceleration is the change in velocity or the change in time. That's the slope. So this is going to be 10 meters per second divided by the change in time, which is 5 seconds. So that gives me 2 meters per second squared. I can see that C is a horizontal line, so it's going to give me 0 for a slope. For D, let's move this a little bit. So for D, let's see, it changes in the horizontal position this much. So it looks like a change of -5 meters per second because we're going from 15 to 10. So final minus initial will be 10 minus 15. That's why I got -5. And change in time, it looks like 10 seconds. So that's going to be the slope. So again, the acceleration, change in velocity or change in time. Change in velocity is -5 meters per second, divided by the change in time, which is 10 seconds. So -5 divided by 10 is -0.5 meters per second squared. So this is going to be -0.5 meters per second squared. And then lastly for E, I start here at 10 seconds. I end at I start at 10 meters per second. And then I end at 5 seconds. So that's a displacement, or sorry, change in velocity of -5 meters per second. Right, because it went down. Or final 5 minus initial 10. And then again, the change in time is 5 seconds. Acceleration is the change in velocity over the change in time. So the acceleration here is -5 meters per second divided by 5 seconds, which gives me an acceleration of -1 meters per second squared. And that goes in here. Alright, next up it says the displacement for A. So this is a velocity time graph, so the displacement is the area under that velocity time graph. So for 5 seconds, that means the base is 5 seconds. The height is 5 meters per second. So base times height. Base is 5 seconds. Height is 5 meters per second. Seconds cancel out, so I get 25 meters. Next up, for this area, I can split it into 2 triangles. I can have area 1 and area 2. So area 2 is just a kind of a square here. It's 5 seconds and 5 meters per second high. So 5 seconds is the base, so area 1 is base 1 times height 1. So it's 5 seconds base times a height of 5 meters per second. So it's 25 meters. And then area 2, it's going to be base 2 times height 2. So base 2 is still 5 seconds. That didn't change. Right, the base is still the same. But the height is now 10 meters per second, 15 minus 5. So it's going to be 10 meters per second, so it's going to be 50 meters. And then I'm going to add both of these to get the total area and the total displacement, because displacement is the area under a velocity time graph. So it's going to be 75 meters. What's the displacement at c? Well, the velocity is constant. So this displacement is just going to be this area. So again, the base is 5 seconds, but the height is 15 meters per second. So it's going to be, so the area there is 5 seconds times 15 meters per second. What is that? Is that 75? 5, 2, yep, 75. So it's going to be 75 meters again for that displacement there. Now for the displacement of D, that's going to be, again, I'm going to break up this area. So I'm going to say this area right here, like this. Again, I'm going to break it up into this. So area of a triangle, I'll call this area 3, and this is going to be area 4, the area of the rectangle. The displacement is 10 seconds, or the base. The base is 10 seconds of that time. So area 3 and area 4. So for area 3, that's my triangle. That's 1/2 base 3 times height 3. So 1/2, the base is 10 seconds. The height is 5 meters per second. So that's going to be 25 meters right there. That's area 3. Area 4 is again just going to be base times height. So base 4 times height 4. So it's going to be base 4 is 10 seconds times height 4, which is 10 meters per second. So it's 100 meters. So add these together, because that's the total area. It's going to be 125 meters. So lastly, I got displacement of E. Again, I want to find the area under this graph. So my base is going to be 5 seconds. That's the base here. But I'm going to split this up into area 5 and 6. So this is area 6. This is area 5. To get area 5, it's going to be 1/2 base of 5 times height of 5. So 1/2, the base of 5 is 5 seconds. The height is also 5 because we go from 10 to 5. So 10 minus 5 is 5. That'd be my height, 5 meters per second. So that's 25 times 1/2, which I think is 12.5 meters. And then lastly, area 6. It's just a rectangle. Rectangles are base times height. The base is still 5 seconds. That's that right there. And the height is also 5 seconds. So that's 25. So I got 25 plus 25 meters. 25 meters plus 12.5 is going to be 27.5 meters. And that's the area there. So there you go. Alright, I'm going to do these last two parts. Well, I'm going to do, I'm going to do this last part in another video. Alright, so hopefully that helped. Bye.